Alright students, today we begin our lesson over Pythagorean's theorem, and we'll be looking at sections 8-7, Pythagorean's theorem. And by the way, today is a day where we get to use a calculator. So woohoo, cha-ching, calculator use, yay. Alright, let's begin. First you can write this down. We use this, we use the Pythagorean theorem to find the missing side of a right triangle. Right triangle. Has to be a right triangle. Can't just be any triangle. Must be a right triangle. This thing only works on right triangles. So don't go use it on every triangle. Just use it on right triangles. Got it? Good. Moving on. Ding, 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 ding. You need to also write this down. A right triangle has three parts. It has two legs, which are the sides that form the right angle, okay? You might want to write that down. You might want to write down a right triangle has two legs. The legs are the sides that form the right angle. This other side, which is the longest side, and you could consider it maybe the slanty side, it's known as the hypotenuse. It's like you're saying hippopotamus, but you stop halfway through and you say nuisance. Hypotenuse. So you have the hypotenuse. Okay, so here we have the hypotenuse and the legs. This is important for the next part. Pythagorean theorem, here it is. A squared plus B squared equals C squared, where A and B are the legs and C is the hypotenuse. Now it's not important which leg you label A, which one you label B, because they're both legs. Just so long as you do label one A and the other one B, you're good. The hypotenuse always needs to be C, okay? Because the two legs, if you square them and add them together, equal the hypotenuse squared. So you could basically look at this. This is like saying leg 1 squared plus leg 2 squared equals the hypotenuse squared. So that's the formula. Kind of looks a little weird, I know. It's probably more complicated than anything we've done so far, but not difficult because we get to use a calculator. Ooh. And this one has a black stain right there. I don't know what happened to it. Ink or someone like smashed it too hard. Not sure. Anyways, it still works. Okay, so next we have our examples. In these two examples, the hypotenuse is missing because we have the sides that form the right angle, so we have both the legs. Okay, so we have both of our A's and our B's. So for this one over here, let's plug everything in. So we're going to say we have 9 squared plus 15 squared equals x squared. So even though we could use a calculator on this, you're going to have to write everything down and show the work that you did to get to this point, okay? And so if we square these, we should be able to get, well, 9 squared is 81 plus 15 squared, which should be 225, is equal to x squared. Because I don't know what x is, so I can't do anything with that. So I add these together, and I end up with 300, and it should be 300, and is it 306, I believe? Yes, 306 equals x squared. Now this is where we need the calculator. All the rest of this you could do without a calculator. This part is where we need the calculator to help us out. You're going to need the calculator to get rid of this square. Now, for the last section, do you remember how do you get rid of a square? What did I say in the last section undoes squaring? What's the opposite of squaring? Like how multiplying and dividing are opposites, adding and subtracting are opposites. What's the opposite of squaring? Square rooting. So if I take the square root of 306 and take the square root of this will tell me what x equals. Wait, I thought we just wanted to get rid of this square. So I understand why you put a square root over here, but why did I put a square root over here? All right, I want you to think about that and answer that question in class tomorrow. Tell me why did I take the square root of this number over here? Okay, let's see if you can figure it out. And if you can't, let's see if you can give me the answer by the time we have class. Okay, so now what we need to do is we need to use our calculator And your calculator has different options. Sometimes your calculator will let you type in the number and then push the square root button. Sometimes it wants you to push the square root button first and then type the number in. You figure out how your calculator works, and that's what you need to use. So we're going to type the square root of 306 in here and hit enter, and we end up with 17.49, and we're going to round it to that point. Okay, so we would get x is equal to 17.49. There we go. And the next one, we write it all down. So we have 5 squared plus 12 squared equals x squared. 5 squared is 25. And 12 squared is 144 equals x squared. Add those together and you get 169. And that's equal to x squared. Take the square root, so the square root of 169 equals the square root of x squared. And if we type this once again on our handy dandy calculator, and we push the square root symbol, and I then type in 169, and this comes out to be a whole number. Works out perfectly this time. Yay! 13 is our answer. So x equals 13. There we go. Now that's what you do when you are missing the hypotenuse, okay? What happens if the hypotenuse isn't missing, but one of the legs are missing? A one-legged triangle. So let's flip over and use the next side. So here we have 2 triangles. So go ahead and write them down, number them and all that stuff. And you can pause the video if you need to do that, but I'm moving on. So once again, if you need to, we could write down the formula again to help us remember. And remember, C is our hypotenuse. So this side with 16 makes the right angle, and this side right here where I don't know what it is, so let's go ahead and put our x there and our x there, our unknown sides. So I could go ahead and say I have x squared plus 16 squared is equal to 20 squared. Okay? So we would then do the rest of the math that we need to do. So I don't know what x squared is, so I just write down x squared plus, well, 16 squared, that would be 256 equals, oops, did I write down 200 right there? That is my bad. That needs to be 20. 20 squared. Now 20 squared is equal to 400. Now, if only I could solve this. The last one worked out so easily. I would square them, I added them together, then I took the square root. If only I knew a way to get this number on that side, then I could take the square root of everything. So much easier. How do I get rid of this number? This is why writing it down is so helpful, because we can actually see the steps. Many of you already know what to do next, but we're going to subtract 256 from both sides. So this leaves me with x squared equals, so x squared equals, and this would be, what, 144? 144, that would be it. And so now we take the square root of x squared and the square root of 144. And I don't even need a calculator for that, and some of you don't either, because you know what the square root of 144 is. I mean, what times itself equals that? Hint, we've already done a problem like this. X equals 12, and that is our answer. Cha-ching. Okay, next. We have this one over here. Let's go ahead and write it down. So if x is one of our legs, let's put it in the front. Makes it easier, I think. So x squared plus, what's the other leg? Besides x, what else do we have as a leg? Well, what else makes the right angle? We have this, and we have 12 squared equals 15 squared. So we have x squared plus 144 equals 225. Okay? So now we need to subtract 144 from both sides. If you did that, that would leave you with x squared equals, well, if you don't know that off the top of your head, just come over here and do the scratch work. Go 225 minus that, which would give you the 1 right there, which you'd have to borrow for that, which would give you 12, so that would be 8. So you end up with 81. Take the square root of both sides, and I think we all know what the square root of 81 is. You should. X equals 9, and that is our answer. Congratulations, you have finished this section. X equals 9. And I'll see you in class. If you have any questions, write them down. Look back over the notes. See you then. Bye-bye.